Alright, so right now we're going to be doing the topic of the sum of an infinite geometric sequence. This is an Algebra 2 with trig topic. So the trick to this topic is that you want to use this formula. The sum of an infinite geometric series denoted by S is equal to the first term in the sequence. First term over 1 minus r. So r would be the number in the parentheses here, right? And the first term is literally the first term in the sequence. So let's look at an example here in our that Alex gives us. So first sequence right here, it's a geometric sequence, and it wants us to find the sum. So first term is negative 3/4. So we'll do negative 3/4 as our first term. And then we'll put that over 1 minus r. So r is the number in the parentheses. So the number in the parentheses is also negative 3/4. So that would be 1 minus negative 3/4, which is just 1 plus 3/4. So if we do on our calculator, we get negative 3/7. This equals to negative 3/7. Okay, so over here we'll put negative 3/7. Alright, next one. Now this notation may seem a little bit confusing. This is where a lot of people get confused, but what most people don't realize is this is just like this. We can rewrite it as the top sequence right here. So the first term would just be like plugging in 1 to negative 2 to the power of k, plugging in 1 for k. So if we do negative 2 to the power of 1, that equals to negative 2. So this is our first term right here. So we've got our first term, which is negative 2, and then we put that over 1 minus r. Now r, like the top sequence, is the number in the parentheses right here. So if the number in the parentheses right here is negative 2, so if we do negative 2 over 1 minus the number in the parentheses, which is negative 2, we get negative 2 over 1 plus 2, which is 3. And this is our answer. But here's the thing. There is a rule. So we said that r is negative 2, but the rule is that the absolute value of r has to be less than or equal to 1. So the absolute value of negative 2 is 2, and 2 is not less than or equal to 1. Therefore, this sequence has no sum. Let's check that. And our answers are correct. Let's try one more just to secure our understanding. Alright, so again, the formula, we have a1. A1 is the first term, so literally the first number here, which is 1/4. And we'll divide that by 1 minus r. So r is the number in the parentheses here, which is 1/4. So we'll replace r with 1/4. So 1 minus 1/4, right? And since the absolute value of r, which we just said the number in the parentheses is 1/4, since the absolute value of r is less than or equal to 1, there will be a sum for this sequence. And we just said that this is our rule, that the absolute value of r has to be less than 1. So therefore this sequence has a sum, so we'll do 1/4 divided by 1 minus 1/4, which is So we'll do a quarter minus 1 divided by 1 minus a quarter, which is a third. So 1/3. And now let's do this next one. So the number in the parentheses right here is -3/7. And -3/7, since it is the number in the parentheses, equals to r. And the absolute value of -3/7, which is just +3/7, is less than or equal to 1. Therefore, this sequence has a sum. So the first term is just us saying -3/7 to the power of 1, which is equal to -3/7. So that's the first term right here, and we'll put that over 1 minus r. So we just said that r is -3/7, so we'll do 1 minus -3/7, which is just 1 plus 3/7. And if we do that on our calculator, we get -3/10. And this should be correct. Now let's try one more. Let me show you another example of a scenario where it is no sum. So we've found an example of one where the answer will be no sum. We've got the sequence right here. So as I said, the number in the parentheses will always be r. So the number in the parentheses right here is -4. So -4 is equal to r. Now the absolute value of -4 is equal to +4. And +4 is not less than or equal to 1. Which therefore means this will have no sum. Now remember, the only thing that makes a sequence have no sum is if r is less than or equal to 1. So now if we check this, I'll do the first one real quick. Actually, let me show you the first one again, just so you can see how to do the sum formula. Yeah, this one has a number before the 4r, so I'll show you this one. Alright, so a1 is the first term. Now the first term here is 4 times 4/5. That is the first term. And then r is the number in the parentheses. Remember, it's not both these numbers, it's just the number in the parentheses. It's not 4 times 4/5, that's our first term. It's just the number in the parentheses. So the number in the parentheses is 4/5, so r equals to 4/5. 4/5. So if we do 1 minus 4/5, we have, let's do this on our calculators real quick, we get 16. So the answer to this is 16. And let's check this, and we should be correct. Yes. Okay, so let's recap real quick. So to do these sum of infinite geometric sequences, you have to use the formula a1 over 1 minus r, and r is always the number in the parentheses, not the number outside the parentheses, but only the numbers in the parentheses. A1 is the first term, so the first number, and if it looks like this, you just plug in 1 for the coefficient right here and the exponent in the place for the exponent, and normally the coefficient will be denoted by I or N or K or any letter. And the only case where a sequence will have no sum is if r, the number in the parentheses, is it's not less than or equal to 1. The absolute value of r is not less than or equal to 1. So thank you for watching. I hope you guys learned something new. I hope this helps you with your Aleks Algebra 2 topic of the sum of an infinite geometric sequence. And